Hello everybody and welcome back to another CS Lightwork video. Today we're tackling the LeetCode Daily 3074 Apple redistribution in the boxes. Thankfully we got an easy one. Let's get into it. You are given an array apple of size n and an array capacity of size m. There are n packs where the ith pack contains I apples, and so that means these are all apple packs and how many apples are in each pack. And there are m boxes as well, and the ith box has a capacity of capacity I apples. So these are all boxes. The first box has a capacity of 4, second one 3, and so forth. Return the minimum number of boxes you need to select to redistribute these n packs of apples into the boxes. And a key note here is note that apples from the same pack can be distributed into different boxes. So when you're thinking of this problem initially, what do we need to do? We need to take all of the apples out and redistribute it into this box. Now, a key note is because we can take apples from the same pack, say the second one, and put some in one box, some in the other, we really only need the sum, right? We need the total amount of apples we're doing to distribute back. So what we're going to do first is get that sum. Now, what do we do with these boxes? Well, we are looking for the minimum number of boxes we can use, right? How would we do that? Well, you would want to look through the biggest boxes first. So what does that mean? Well, in this case, we have 6 total, and we want to use the smallest amount of boxes, right? So first, we'd want to use this box with 5, and then we have 1 left of our 6 total. In this example, we could use any, but we'd want to use 4 just in case there were more, right? So now how do we code that up? All right, so this is what your code is going to look like. So as you can see here, first we're getting the sum of an apple. In a different language, you might have to iterate through, keep a rolling sum, but we're getting the sum of everything in here. And now we're just going to declare those boxes that we're going to return, the minimum number of boxes. And then we are going to sort backwards the capacity. So we'll have 5, 4, 3, 2, 1. And so that way we can always grab the biggest box from the beginning and iterate through. And that is what we're doing right here. So once it's sorted from biggest to smallest, we go through the biggest box and we take the space the biggest box has, so the first index in that case, away from the sum of our apples until essentially we don't have any apples left. We keep track of the box every time we go through. And then finally, if we have no apples left, break and return the number of boxes. All right, and the runtime complexity for this is going to be O of n plus m log m. That's because the total sum is going to be O of n, right? N is the length of that apples array, and then you have to iterate through all the elements, so that's O of n, and then you have to add on the cost of sorting the capacity array, and that's going to be m log m most efficiently, and then that for loop at the end is negligible because O of m will be overtaken by the capacity sort, so it's O of n plus m log m. That's pretty much it, guys. Like and follow for less. Peace.